that quantum is not just computing. We'll be mostly exclusively talking about computing, but quantum is just a technology that the basis of communication gives you communicating, gives you sensing, gives you a lot of interesting and evolutionary things. It's happening very, very quickly, very fast, and we have very, very interesting, very promising.
In quantum is at this stage is stunning. Could be usable, better corrected, and create more reliable qubits, and that was all in the future. Well, in 2 years, we went from 0 to 50 or more than 50, and that's quite stunning at the rate. Yes, there's more maturity needed, but in my opinion, quantum has gone from an if, a science experiment, waiting to be seen if you can attain quantum mechanics in the way we need to for it to become a computer or a sensor or a network element, to maturing it now in an accelerated pace to get it to real commercial deployment.
I think because it helps make this more tangible, it helps to think about the problems that have quantum solutions potentially. So if one of you would like to help us think about that.
Yeah, so there are many interesting problems that we are facing. Just we need to think of quantum as think of it as learning how to dive. Usually it takes you a month or years to dive, but eventually, when you are able to dive, you have a car and you can dive. Quantum computing is like learning how to dive a rocket, a spaceship. We don't have the spaceship, but if you start learning about how to pilot the spaceship, build the spaceship, dive, it's already too late. There are most of the problems that we are facing today are not computers that have been computers that have been produced, and we have demonstrations. The problems that we have today is mostly engineering. And if we learn one thing from history, engineering problems eventually will be solved. It's just a matter of time and being prepared.
You've heard about some of the applications though.
Yeah, that's the exciting part. Whatever we say today is going to be proven wholly inadequate in terms of opportunity.
Robotics.
But I think it's important to realize why people looking at, or why is the industry looking at quantum convenience, right? Normally we build faster and faster computers. Over 30 years, Moore's law trained us to say, hey, build chips with more transistors that can run faster and more power, innovate on those transistors and create CPUs, GPUs. Quantum isn't just about a faster processor. Quantum is about looking at a problem fundamentally different and exploiting the high degree of parallelism in both data representation and compute. So you can do parallel things. Over 30 years again, we learned to go faster. It's not just increasing one thing to go faster, but using many things in parallel. So quantum brings us there. But also the most exciting part of this, quantum brings us the ability to model and understand a set of things that we could not have done before with a digital representation. Think about understanding how a molecule binds with another molecule. Now you could say that's a theoretical problem. It's not. If you're doing carbon sequestration and you're creating synthetic materials that absorb carbon dioxide from the air, that is exactly what I just described. If you're trying to create new materials that take drugs into your body, take them safely to the place where it has to be released in a very precise kinematic manner, we're talking about quantum phenomena. So finally, we now understand that the laws of physics at certain scales of things that describe those things can now be computed natively in quantum computing. And that's really the beauty of this Not only will it let you do things we do today faster in certain cases, it let us do things that we've never been able to do.
Absolutely. You know, probably the biggest shift that I've witnessed in the 10 years that I've been covering this topic has been, we went from all this hype around quantum supremacy, right? And this idea that, you know, there would be like a winner to this computing race, to more of a conversation around collaboration, enabling how these different, you know, we're going to have GPUs, CPUs, QPUs, who knows what else is coming up next, right? All working together. And maybe that's something we can talk about too, the interplay now between quantum and AI.
Yeah, that's a great topic if you allow me to. I mean, if you look at it, quantum isn't just replacing one layer. Like, you know, if you look at classical again, software is there, all of those things exist, you're replacing the engine underneath it with some software abstraction, you generally keep going. Right? Quantum requires a grounds-up new way of thinking. All the way from the hardware to how you even program it and how applications are written, changes the way you think of even algorithms to do standard things. Requires collaboration, right? You don't get to working these new capabilities in an upstack manner, in a full stack manner, by only one company working. None of us have the ability to have the world's best talent in everything. Even as large as a company in the there's academia, there's a fundamental role for academia. We're bringing quantum mechanics into the engineering realm, as you just said. So there is a broad set of needs of people to put their heads together and work to create this grounds-up infrastructure for quantum. And I'm very happy to see it is, even as there is obviously recognition that quantum is a source of strategic advantage in economies and other places, there is a very healthy level of academic collaboration that's existed in the field of physics for years.
Absolutely, well, absolutely. To that point, with space tech or, you know, different types of mineral mining, there's a lot of things happening right now in this space of deep tech that require all hands on deck, as we like to say in the US. It's going to take everybody working together to really see some of these things align. And what about the state of play for quantum within the GCC, locally and beyond?
Yeah, I mean, if you asked me this question 5 years ago, then the answer would not be very optimistic. But since quantum supremacy, actually quantum supremacy is one of the things that has received a lot of criticism around the world, because it was basically just a demonstration of something that a quantum computer can do, no other classical computer can do, but the next problem is itself completely useless. Everybody knows that. But you know, if there's one thing that quantum supremacy did for the community of quantum computing, it was just getting people excited. So everybody started listening to quantum supremacy, regardless of what the constituency is. And this is around the time where most of the countries around the region started to pay attention to quantum computing. And this is literally where we started becoming interested. And we're extremely lucky because our first quantum initiative was actually backed up by the government, so it was the government who actually believed in the potential of quantum computing. And then we took a more a wider approach. So we said, okay, the quantum supremacy happened in computing, but why don't we just do quantum information? So why don't we investigate quantum communication, quantum sensing? These are all the quantum technologies. And then we believe that this is going to be the way that will eventually lead us to a competitive advantage. We are in the early stage of this technology. If we don't invest in it now, we'll not be among the nations that lead it in the future.
What do you think the field needs as a breakthrough to really propel this forward, to make it more practical and useful? Is there something, is it easy to pinpoint, or is it a broader thing? What are you waiting for?
Well, I mean, I can answer that question on multiple levels. The technology level, which is where we believe to go all our lives, it's breakthrough technologies like quantum error correction or integrated optics are the things that make these computers bigger and smaller at the same time. Bigger in terms of performance, smaller in terms of footprint. But I think the biggest breakthrough comes when technology meets usage. Right? So the biggest breakthrough, I mean, could we say in the next 5 years, before this decade is over, we'll see the first completely computer-generated drug that is a combination of AI, generative AI, and quantum computing? Yeah, possible. So it's that breakthrough that I think the collaboration between the use case and the technology, and not the technology looking for a problem to solve, or the use case trying its best not to use new technology, that has to break through. But I think it's key, you know, it's chat GPT moment, and people ask me this question all the time. It is not going to be like the consumer chat GPT. It'll be more like fundamentally and quietly changing the way discovery and creation of new products are done.
Sure. Well, it's the history of technology, right? You think of, we needed to get into a car and drive it and say, seatbelts would be a wonderful addition here, right? So you put something into the hands of people, they use it and they find new ways to use it and everything evolves. But it's interesting to me because quantum, for the longest time, it was framed as, I would say negatively, but quantum encryption, just wait, everything will be unraveled and we won't have, more with supremacy and then also with slightly negative, and now we're coming around to like, well, maybe we'll discover new materials.
Yeah, quantum is a tool, like I said, is very well versed with this. It's a tool, and it kind of got its public notoriety in the beginning as it's going to break encryption and bring everything down. But it's that same tool is also distribution, right? Being able to create post-quantum or PQC, post-quantum cryptography, using this powerful method is the other side of the coin. But to me, really, it is about very interesting use cases that, as we look today, it brings a combination of AI and quantum. AI is, I've said this before, it's kind of like a gigantic autocorrect. It, based on what it kind of has seen and understands of language construction, it can finish. But as we get to using this amazingly powerful tool in ways that where we can do things we couldn't have done before with just speed and automation, quantum comes in. Like, what if an AI agent was actually trained to understand quantum mechanics and could actually predict how, either reaction pathways, chemical properties, or other things that were not work solutions. Then now you have the power of AI being trained with the power of quantum to achieve something neither of them could achieve alone. And more importantly, it couldn't have been done with classical computing.
Absolutely. It makes the whole thing feel bigger, doesn't it? So how do you see governments and companies preparing for this next era of quantum?
So I think what we're really missing now is the kind of integration between all these technologies. The main problem I see is that everybody's talking about quantum and kind of forgetting about the other technologies. So personally, I think that the first big quantum computer, the quantum computer that will find a cure to cancer or solve some optimization problem, is not a single quantum computer. It's probably going to be many smaller quantum computers connected to each other and with computation distributed. You cannot do this with the quantum computing. You have to merge this with the quantum communication, because when you build the different quantum computers, the way to connect them is the secret of quantum computing, which basically uses quantum communication. So what we really need to focus on is bringing all these quantum technologies together and living more together. Only then we'll achieve the balances and the potential of quantum technologies.
All right, we're in our final 2 minutes. What's a prediction for the next 5 years for BJJ?
Well, I kind of gave you my little guess.
Sneak peek
It's
earlier.
probably in the area of materials or life sciences, we would see self-healing systems. But I wanted to quickly cover something Dr. Saib said. Right? I think what the world has learned through technology cycles, first came the cloud, then came AI, and now through the quantum revolution, they all build on top of each other. And so it's important to both a strategic advantage, industrial advantage, and even national security to actually start that journey. Fast following in this field is getting more and more expensive. The second is actually to have what I call the whole trinity together, right? Which is use cases, infrastructure, and workforce. All being part of a holistic policy to build up a quantum frontier, and I completely agree with Dr. Said, not as an isolated thing or competing with other technologies, but as a complement.
So yeah, I think my prediction is a very bold prediction. Don't quote me on that. So I think somebody will be able to build a quantum computer, ultra-large quantum computer, and a big quantum computer. But I think that will not create the ChatGPT moment. The ChatGPT moment will be created when somebody gets access to that machine and starts playing with it, and you find an application that really revolutionizes everything. And that application might not be one of the applications we just talked about. It might be something else.
Absolutely. Gentlemen, this has been a wonderful conversation. Thank you both for your time, and thank you to all of you for being here this afternoon.